For as long as I can remember, there's been this one piece of cosmic trivia that felt totally set in stone. Our galaxy, the Milky Way, is on a collision course with Andromeda. It's like cosmic destiny, right? But what if I told you that one of the most dramatic events in our future just became, well, a lot less certain?
And look, this wasn't just some half-baked idea. For over 100 years, this was basically textbook science. The story was always the same, a massive, head-on crash between the two biggest galaxies around here. We were picturing the ultimate galactic demolition derby, and our solar system had a front-row seat.
Well, guess what? That's exactly what just happened. The latest science, using our most powerful telescopes, has basically taken that cosmic certainty and just flipped it on its head. The whole story of our galaxy's fate, yeah, it's no longer a sure thing.
Okay, so let's back up. Where did this whole idea of an unavoidable crash even come from? Well, for decades, astronomers looked at the light coming from Andromeda and saw it was blue-shifted. It's kind of like the sound of an ambulance siren. You know how the pitch gets higher as it races towards you? Same idea, but with light. Light from something moving towards us shifts to the blue end of the spectrum, and that told us Andromeda was hurtling our way at a mind-boggling 110 kilometers per second.
But here's the thing. There was always this one massive piece of the puzzle missing. We knew it was coming at us, but we couldn't measure its transverse velocity. That's the fancy term for its sideways motion. Think about it like this. A car is speeding down the highway. You can see how fast it's coming towards you, but you have no idea if it's in your lane and about to hit you, or if it's going to just zip past in the next one. For decades, scientists just had to assume that sideways motion was basically zero, which pretty much locked us into that head-on collision scenario.
And this, right here, is where the whole picture gets a massive update. All that new data has completely rewritten the old story. That simple two-car crash model, it's out. What we have now is something way more complex, and honestly, a lot more chaotic.
And here it is, the bombshell. According to these incredible new simulations from 2025, the chance that our galaxies will actually merge in the next 10 billion years is no longer 100%. It's 50%. Just a coin flip. Now, this isn't just a wild guess. This is the result of a ton of computational power. Researchers took the incredible deep space vision of the Hubble telescope and mashed it up with the super precise measurements from the Gaia Observatory. Then they ran 100,000 different simulations. They were tweaking every possible variable you can think of, the exact mass of the galaxies, their precise speeds, to map out every single way this cosmic meetup could go down. It's a staggering achievement, really, the kind of cosmic fortune-telling that's only possible right now in this unique moment where we can still see the universe's history. So what changed the odds so much? Well, it turns out we were looking at the problem way too simply. It was never just about our two galaxies. The local group is more like a giant game of cosmic billiards, and there are other huge players on the table that are totally changing the angles of the shot. So check this out. If we run the simulations with just the Milky Way and Andromeda, like in the old days, the chance of them merging is actually a little less than half. I mean, that alone is a massive shift from the 100% certainty we used to talk about.
But now, watch what happens when we add in the local group's third biggest player, the Triangulum Galaxy. Its gravity basically acts like a brake on Andromeda. It slows it down just enough that it's easier for the Milky Way's gravity to grab hold of it. So with Triangulum in the game, the probability of a merger suddenly jumps all the way up to 66%.
Okay, but now let's see the opposite effect. We add in the Large Magellanic Cloud, or LMC. That's a huge satellite galaxy orbiting our own Milky Way. Well, it gives our entire galaxy this powerful sideways tug. It literally yanks the Milky Way a bit off course, which makes a direct hit with Andromeda less likely. With the LMC's influence, the odds of a merger plummet down to just 33%. So what happens when you put it all together? It's like a cosmic tug of war. You've got M33 pulling Andromeda back, making a crash more likely, and you have the LMC pulling the Milky Way to the side, making a miss more likely. And what's crazy is that these two opposing forces almost perfectly cancel each other out. The final odds? They settle right back in the middle, at a clean 50-50 split. So, while the Great Andromeda smash-up has been downgraded to a maybe, these new simulations revealed something else entirely. Another huge galactic collision isn't just likely, it's a guaranteed, absolutely locked-in event.
Yeah, that sideways tug from the Large Magellanic Cloud? It comes at a cost for the LMC. It's losing energy, which is sending it on a death spiral right into the Milky Way. In about 2.4 billion years, it's going to be completely swallowed by our galaxy. This isn't a maybe, it's a certainty, and it's going to be a pretty dramatic event too. It'll light up our central supermassive black hole and make the giant halo of stars around our galaxy 5 times more massive. So this leaves us with two very, very different futures. On one hand, we have a certainty, a pretty violent merger with the LMC that's going to reshape our galaxy in about 2.4 billion years. And on the other hand, we have a total toss-up, a 50-50 shot at a much, much bigger collision with Andromeda, probably way further down the road. Okay, so let's say the coin lands on merger. What does that actually look like? Well, it's not going to be some single explosive crash. It's more of a long gravitational dance that takes about 2 billion years to play out. Just imagine these two huge spiral galaxies swinging past each other for the first time. Their gravity would pull out these enormous 100,000 light-year-long tails of stars. They'd fly apart, but gravity wouldn't let go. They'd slow down, stop, and then fall back in for another pass, and then another, until finally they merge into one gigantic new galaxy, which people have nicknamed Milky Way. Now, I know the word collision sounds absolutely terrifying, but we have to remember the insane scale we're talking about here. Galaxies are mostly just empty space. I love this analogy. If stars were ping pong balls, they'd be separated by over 3 kilometers or about 2 miles. So while the galaxies themselves merge, the individual stars, including our sun, will almost certainly just pass right by each other without ever coming close to hitting anything. And the result of this merger would be a total transformation. You'd take the two beautiful, flat spiral galaxies we know and love today, and they would combine into a single, giant, roundish blob of stars, what we call an elliptical galaxy. It'll be less of a structured disk and more of a massive, glowing cloud. And it would contain all the stars from both galaxies, creating this new behemoth with over 1.3 times trillion stars. But here's the real kicker in this whole cosmic drama. Should we even be worried about any of this? I mean, the LMC merger is over 2 billion years away. The Andromeda merger, if it even happens, is like 7 or 8 billion years away. Well, our own sun is on a much faster timeline. It's getting hotter and hotter, and in as little as 500 million years, it will have basically cooked the Earth so much that our oceans will boil away. We'll be long gone before either of these galactic showdowns even happen. So let's zoom out one last time, way further out, beyond mergers and planets, to the ultimate endgame for our entire cosmic neighborhood. Because when you look at the very, very longest timescales, the biggest force at play isn't gravity. It's the expansion of the universe itself. In about 100 billion years, the accelerating expansion of space is going to carry every other galaxy so far away from us that their light just can't reach us anymore. They will literally vanish from our sky. All that'll be left is that single giant galaxy formed from the merger of all our local neighbors. We'll be an isolated island universe floating in a sea of unending, absolute darkness. And that leads to this really profound idea. Think about it. Future astronomers living in that lonely galaxy would have zero way of knowing that a larger universe ever existed. All the evidence would be gone. It means that we, right now, are living in an incredibly special and fleeting moment in cosmic history, a blessed period where the grand story of the cosmos is still visible to us. Which kind of leaves us with one final thought to chew on. We've gone from a certain fiery galactic collision to a cosmic coin toss, only to realize our own sun will decide our fate long before any of that happens. And eventually, the universe itself is going to literally erase its own history from view. So, if all this cosmic history is one day just going to disappear, what does it mean that we are here right now with the ability to see it, to understand it, and to tell its story?